आज ही डाउटनेट ऐप डाउनलोड करें। डाउटनेट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सोल्यूशन पाओ। डाउनलोड नाउ।
In this question, we need to draw the graph of the function f(x) equals to 1 by x to the power x. Now to draw the graph, we firstly need to find out the extreme point. So let us write it as y equals to 1 by x to the power x. And to find out the extreme point, we'll have to differentiate it. So to differentiate it, let us first take log on both sides. So we will have log y equals to x log 1 by x, since we know that log x to the power a is equals to a log x. Also, this will be equals to minus x log x, since log 1 by x can be written as log x to the power minus 1, which will be equals to minus log x. So we got the value of y as minus x log x. Now we can easily differentiate it. So dy by dx will be equals to, we'll differentiate this using product rule, and product rule says that ddx of uv is equals to u dv by dx plus v du by dx. So differentiating this, we will get, we'll take minus common. Firstly we'll differentiate x, so we will have 1, then log x, and then x into differentiation of log x is 1 by x. So also on the left hand side, differentiation of log y will not be dy by dx, it will be equals to 1 by y into dy by dx, since the differentiation of log y is 1 by y. Now this can be written as minus log x by x, that is 1. So we got the value of dy by dx as minus, in place of y we will write down 1 by x to the power x. So 1 by x to the power x, and here we have 1 plus log x. Now let us analyze our dy by dx. Note that the value of the function fx was equals to 1 by x to the power x. So we can say that the domain of this function fx will be all x greater than 0, and for all x greater than 0, this will never be negative and it will always be greater than 0. Now let us equate dy by dx as equals to 0. So only this can be equals to 0. So we will have 1 plus log x equals to 0. That is log x equals to minus 1. Also, this log was taken to the base e. So this minus 1 can be written as minus log e, and this will be equals to log base e to the power minus 1, which can be written as log e 1 by e. So comparing our left hand side and right hand side, we get the value of x as equals to 1 by e. Now we will analyze our dy by dx in and around x equals to 1 by e. Now for values of x greater than 1 by e and taking log both sides with the base e, we will have log x greater than minus 1, and so 1 plus log x will be greater than 0, and if 1 plus log x is greater than 0, and here we have a negative sign and this is also greater than 0, dy by dx will be less than 0, and for values of x less than 1 by e, we will have log x less than minus 1, that is 1 plus log x less than 0. So this part is less than 0, and here also we have negative, and this part is greater than 0. So dy by dx will be greater than 0. So we can say that before x attains 1 by e, the slope of the graph is increasing. So it will look something like this. And after x equals to 1 by e, the slope is decreasing. So after x equals to 1 by e, it will look something like this. So we can say that x equals to 1 by e will be the point of maximum. So we got the point x equals to 1 by e as the point of maximum. Now let us find out what will be the value of limit x tending to 0 fx and limit x tending to infinity fx, and that will help us draw the graph. Now fx is equals to 1 by x to the power x, so this will be equals to limit x tending to 0, 1 by x to the power x. This can also be written as limit x tending to 0 e to the power log of 1 by x to the power x, since we can write any number a as e to the power log a. Now let us simplify this and let us leave it for later. So this will be equals to limit x tending to 0 e to the power, this x will go here, x log 1 by x. This will be equals to limit x tending to 0 e to the power, log 1 by x can be written as minus log x, so minus x log x. We'll simplify it further. So limit x tending to 0 e to the power minus log x divided by 1 by x. Here we'll apply the L'Hospital rule, which says that limit x tending to 0 fx by gx can be written as limit x tending to 0 f dash x divided by g dash x, provided it is in the form of 0 by 0 or infinity by infinity, etc. So this will be equals to limit x tending to 0. Here it is in the form of infinity by infinity. So e to the power minus differentiation of log x is 1 by x, and differentiation of 1 by x is minus 1 by x square. So minus minus plus 1 by x square. So this will be equals to limit x tending to 0 e to the power x, and as x tends to 0 it will be equals to e to the power 0, that is 1. So we got the value of limit x tending to 0 fx as equals to 1. Now let us find out the value of limit x tending to infinity fx. This will be equals to limit x tending to infinity 1 by x to the power x, and as x tends to infinity this will tend to 0, and so this will be equals to 0. And now we can proceed to draw our graph. So let us suppose that this be our coordinate axis. Now the value of the function as x tends to 0 is equals to 1. So let us suppose that this point be x equals to 0. This point here be x equals to 1 by e. So as limit x tends to 0, the value of the function is 1. So let us suppose that this point be 1. And the function is maximum when x is equals to 1 by e. So it will look something like this. Here it will attain maximum and then it will slowly converge to 0, since the value of the function as x tends to infinity is equals to 0. So this is our required graph of the function. This point here will be equals to x equals to 1 by e, and this is the maximum point. So this is the graph of the function fx, which is equals to 1 by x to the power x, and that's our required answer.
क्लास 6 से 12 से लेके नीट IIT JEE मेंस और एडवांस के लेवल तक 10 मिलियन से ज़्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।